Okay, hello. I just wanted to go over the mid-module assessment with everyone, and just point a few things out. Um, yeah, there were quite a few issues. You know, as always, teacher assign an assessment and think it's going to be so easy, or at least doable. And I think for some they got quite a bit of the material, but yeah, there's still confusion with others. So I hope you please do use this assessment of the assessment to go ahead and talk to your children about it. Okay, I just wanted to show you a few things. First. Well, actually, one thing first, and this is how I'm quote unquote grading or assessing these. Is in a four-point scale here. So you'll see. The kids will either get a 1, a 2, 3, I'm not sure why I keep messing that up, 3 or 4 on their, for each question. In fact, actually, I've gone in between. Sometimes I've been giving 2/3, so you'll actually see 2.5 at times, maybe 3.5, 1.5. Okay, so I am going to the half points. Just to show you, just give you an example, here is question 1 on the module 1 mid-module assessment, and it just kind of gives you the criteria that the children have to meet to receive such a point. Here's here is 1, 2, 3, and 4. Okay, you can see here this is the question number right here. So question 1. If the student, answered incorrectly, they may get a 1. If they were unable to compare, from this example, anything, any correct pairs in this question, then if it was obvious that they really did not know what they're doing, they'd get a 1. It says here, so number 2, they may or may not actually have gotten the answer correct. Okay, in this case, it was about identifying whether the relationship was proportional or not. But they were able to complete at least a few correct pairs, maybe on values on the table. Okay, and now mainly what's going to create a difference between the 3 and the 4 is this idea of explaining. Okay, very often it says to explain your answer. And I'm correctly answered this relationship, and then here the student provided the correct setup, and they also explained it really well. So that's going to be getting to 4 in some cases, if there's not a real good explanation, or an explanation that would would show me that they truly do understand, and then a 4 is not going to be attained. Okay, so I just wanted to show you that. I just wanted to let you know how these are being graded, because when I send these home with them, they'll have numbers at for each question. Okay, I'm actually tracking that too and getting averages for the kids as well. It's not something I'm putting at the top, because these assessments are to be worked with, these mid-module assessments, and to help. Okay, and here's that page 2, which is that's question 3. That's just more of the rubric, grading rubric. Okay, so we're going to start now. We're going to start going over these questions one at a time. Well, the average score on this first question was 2.35. Some had a good deal of success with it, but many did not explain. They just drew the table, because the question down here was, is the relationship between Josiah's pay and Tillery's pay rate proportional? And then explain your reasoning using a table. Okay, so they needed to add some sort of text to it as well. And your basic table went like this, and I think most of the kids did a really good job. They had Josiah, and they had Tillery, and we know that year, this would be the year, so year 1 Josiah was being paid $14 per hour, and then Tillery 7. Okay, and that all comes from right up here. Okay, and what they were told then is they had been told that each one is going to be given a raise of $2 per hour for every year. Okay, every year. All right, and so then, again, if they had, just 2-3 pieces of, information here, 3 years worth, for example, that was good enough. Okay, because they know Josiah is going to go up to 16, Tillery is going to go up to 9, Josiah is 18, Tillery up to 11. Okay, because they're both being added. And this idea of being of adding, remember, was a real key. You can't just add the same number to two values and expect that they're going to remain proportional, because that just won't ever happen. And here we can create our ratios here, and we know this was, if we go to Josiah to Tillery, was 14-7, which we talked about in class. We knew was 2-1. Okay, and then but then we looked at 16-9. Okay, and we can tell right now that's not proportional to 14-7, because 16-9 is not equivalent to 2-1, and this was 18-11. So the kids that said no, it was not proportional, got credit for that. Then if they were able to actually then write an explanation, or chose to write an explanation, they would have gotten a full, complete 4. And I'm not sure if there was anyone. I think there was only one person in the class who explained 2. They might have written something to the effect of, no, the relationship is not proportional. Proportional as the same number, or the same amount, was being added to each every year. Okay, something to that effect, or I know it's a mess, and of course they would do it more neatly, but yeah, so they would be giving full credit if they actually wrote an explanation. I want you to really, if you could really emphasize that with them. Lots of credit as well for creating this graph, or this table, a functional table that made sense using the correct data as well. Okay, and let's go down to the second one, which is, I'll pass it there. Number 2. Okay. All right. So number 2. A recent study claimed that in any given month, for every 5 text messages a boy sent or received, a girl sent or received 7 text messages. And right here, right away, for every 5 text messages, Okay, so again, the question is going to be here, is this relationship proportional, between the texts received and sent by boys and girls? Okay, and then again, this idea of explaining your reasoning using a graph or coordinate plane. I think most went ahead and used a table. I'm not sure. Well, actually, some did use a graph, but not as many used a graph as I would have hoped. But anyway, if you did create this graph, okay, because they want, again, these assessments, they want to know that the kids can do these things. Now, we talked about in class when we went over this. We didn't get to go over the entire thing, but we did talk about dependent and independent and where they land. And we identified that the x-axis here was the independent, and y was our dependent variable. And I want them to become more and more comfortable and familiar with these terms. Now, this y here is dependent because the way this is written, it says for every 5 text messages by a boy. Okay, for every one. For every 5 of those, 7 were sent or received by a girl. Okay, so there we go. 5 to 7 is giving our ratio. But this for every 5. For every 5. So that is independent. 1, 2, 3, 4, 5. So for every 5 of those, there were 7. 1, 2, 3, 4, 5, 6, 7. Now the way it's written, the Y is dependent on the X, or the girl's text sent and received or is dependent on the boy's text sent and received. Yeah, and of course in real life that's not true. Like we said in class, I mean, it's not like girls, the boys send 5 text messages and all of a sudden the girl's got to send 7. It just doesn't work that way. But the way it is written, it's more or less written as an independent. So we could just mark that point, plot that point, and then it would have been good again if they had gone ahead 1, 2. Wait, hold on a second. Okay. 1, 2, 3, 4, 5, and then another 7. 1, 2, 3, 4, 5, 6, 7. Boy, I'm really making a mess here, but up here somewhere. Here's our other point. And then they would have just drawn a line, okay, and that line, and would be best for them to do is to go ahead and do this as well, is to actually label those points, okay. And again, so if you could just again stress with your children to do all of this, I would like, and this one would be here, would be girl texts, and then boys texts. So if we could make sure, if you can make sure that they are doing this, they are they are doing a few different things. They are labeling their axes, okay. Boys text, girls text. They are labeling points on the coordinate plane, plotting those points as well. Okay, so that would be that's really important. If they did all that, and then again, of course, wrote an explanation. We'll see the average score on this number 2 was 2.58, and had two students actually get a full 4 on this one. Okay, again because they drew a graph, did a good job of that, and explained in writing. Okay. All right. So on to the next. Okay. So the rest of the questions were based on this graphic right here. This graphic. So let me go ahead and read that. Read the main part of the question. Then we can go over each one and I'm going to go ahead and maybe take a picture of this, see if I can. Okay, take a picture of that. I thought I did. I'm not really sure. But I want to make sure that do this. I'm just going to try to save this so we can use this over and over again. Okay, good. I do have it a couple of times now. Okay. So when a song is sold by an online music store, the store takes some of the money and the singer gets the rest. The graph below shows how much money a pop singer makes given the total amount of money brought in by one popular online music store from sales of the song. And again, just to highlight the different parts of this graph, remember we had just talked about this right here, the making sure they're doing things like labeling their axes. Okay, so you have sales of online music store, paid to pop star. Another thing to really recognize, and this is a place where the kids went wrong, many of them, is to just again to recognize what is the X. The X right here, or the independent variable, is the sales by an online music store. Okay, and then this was independent. Oh man, sorry. This is really messy. Independent, and this is dependent right here, and that's our y-axis. Okay, well, my recording just paused on me because I was running very low on battery. I went and found an iPad charger. So I'm back. I'm not sure where I was, but I just wanted to again reemphasize this idea of the independent variable being that on the x-axis here, dependent on the y. makes a lot of sense, whereas it didn't make as much sense in the texting example. It makes a lot of sense here because the sales by the online music store, I mean, the money paid to the pop star is very dependent. It depends on sales by the online music store because they are the ones that pay. These are called royalties. They pay royalties to the pop singer, the pop star, for all that's sold there. They then pay the pop star. So the truth is, there's no other place on this graph that the paid to pop star could be. It needs to be on that y-axis, and therefore you'll see where the numbers on this axis, where they end up in our when we create a coordinate point. Okay, with this point right here, you can see that there was $200 paid to the pop star, and you can see that exists right there because these coordinate points are always plotted x, comma y. Okay, and this is real crucial in one of the, I think it was 3E, where a lot of the students got that question incorrect because they did not plot the point, or they did not designate this point in specific terms, with online music store sales being the X, and pop star sales, pop star money being the Y. Okay, so here's this graph. We'll come back to it. Actually, let's go over here. There it is again, and let's go one more time forward, and I'm going to go ahead and go down, scroll down to our questions. Okay, oops, I'll go so fast. Okay, so here we are. We are now at question A. So identify the constant of proportionality. Okay, and this is what we what I am looking for in this problem. Okay, the constant of proportionality between dollars earned by the pop singer and dollars brought in by sales of the song. Okay, so I'm not asking here for an explanation, or they are not asking for an explanation. They just want it written in the constant of proportionality formula, which is K equals something. Okay, so K equals something. Okay, if the children had done this, okay, they would have maybe they would have drawn a table. Okay, so remember the X was online sales, the Y was pop star. I'm just going to write it like this, save you all some time having to listen to me over and over and over again. And then the K, of course, is our constant of proportionality. Okay, so if we plotted a few points that we can see, for example, we had, here's 240. So we have 200 online, 40 pop. Okay, now our K, remember our K is Y over X, okay, because it's Y as a function of X, okay, our dependent variable as a function of our independent variable, okay. So in this case, that's going to be 40 over 200, which is also the same as 1 over 5. Okay, and again, if we want to just check that, we could plot another point. Let's plot this one, 600, 120. So 600, and again, this is our X. Here's our Y, 120. But our K is, of course, Y over X. So that's 600. Excuse me, it's not 600. It is 120 over 600, which also reduces to 1 over 5, 1/5. So our K is 1 over 5. Some children wrote K equaling 0.2, which is okay, which is good. Okay, it's correct. I would have liked them to have gotten to this answer using the table format here, because it's very easy to see. Okay, this is one part of this that I'd really like you to go over. Let me see, my average score here was 2 out of 4. And there were quite a few kids who received no credit at all. Well, received 1 point. I mean, you never receive 0, okay? because they supplied some sort of answer. So they got 1. So several students got just 1 point, which means they got it wrong. They didn't really show any understanding. Okay, the constant of proportionality. Constant of proportionality is written like this: K equals the y value over the x value. Okay, this is the y, this is the x, and that's x divided y divided by x. Right? In this case, very easy to see. It was 1 over 5, or 1/5. If they had written it like this, there was credit given for that as well. Okay. All right. So let's go to our next problem. That was A. Let's go down to. Oops, I did that again. Okay. So having trouble going a little bit at a time here. Let's go down to B here. Okay. So now write an equation. Okay. Again, there's no explanation needed here. I just want the equation, and an equation in this case is going to be written, and let me just show you here why I know this. Write an equation relating the dollars earned by the pop singer to the dollars brought in by sales of the song. So what I need to do is I need to relate this. I need to relate the y. So if I'm going to relate the y, I have to write it in this terms. Y equals, okay? Y equals, remember, k of x, okay? Or actually, probably more correctly, you're going to see it this way. Probably more when you start going further on into our studies. K times x, okay? K times x. So all I want to do is write an equation. I don't need, I don't need specific numbers from the graph. Okay, what I do need is my constant of proportionality, which I figured out already is 1 over 5 right here. Okay, so y equals 1/5, which is my k, x. Okay, and that's it. This is the equation that needed to be written. Let's see how we did there. Again, that was also an average of 2 out of 4. Anybody? I see I had 2 students got 4s on this one. Okay, so yeah, y equals k times x. That is the equation that relates dollars earned by the pop singer to dollars earned by the song and the sales of the song. Okay. So that is that answer right there. Had to be an equation. Some children did not use an equal sign. And any equation, is always going to have an equal sign. This idea of equals. Okay. Alrighty. Okay, so let's go on. Let's move down to C. Okay, so according to the proportional relationship, how much money did the song bring in from sales in the first week if the pop star earned $800 that week? All we need to do, we have our equation. We have y equals 1/5 x, or 1 over 5x. If we have some data already, what we know, and again, if we're to turn this around, now we know, in this case, we know y. Okay, 800, because that's the pop star. Remember, this is the pop star. Pop. And this is online sales. Okay, that's the x. And this, of course, is our constant. Okay? We know this because we have this, we wrote this already. We could plug this in and we could figure this out in many different ways, but we could also write it differently, and we can write it in terms of x, okay? And then x is also going to, I'm just going to write down here. So x equals rate, so r over y. Okay, we can do it that way as well. But if we just go ahead and plug it in here, we can just get all this out of the way here. Okay, so if we do that, 800 equals 1/5 x. So we need to decide, or need to calculate, what is the value of this if 1/5 of it is going to equal $800. Okay, and what we can do, as we can do with all equations like this, is we can go ahead again, and we talked about this some time ago, is to isolate this x. So this x is going to be on this side alone by, if you remember, dividing by 1/5. Okay, because remember, 1/5 times 1/5 is going to give you 1, so that's going to be 1x. But remember now, when we divide by 1/5, what are we doing? We're actually, remember, multiplying by the reciprocal. Okay, and that's of course going to equal 5/5, which equals 1. Okay, and now over here I have to do the exact same thing. So if I do 800 divided by 1/5, what I'm actually doing, or 800, I am actually doing 800 times 5/1, which is 800 times 5, which equals 4,000. Okay, so 4,000 equals x, or x equals 4,000. Okay, now there are other ways to do this. We could also do, if we know, that y equals 800 equals 1/5 x. Here's another way to do this if you're not comfortable with that equation way, which we need to get comfortable with soon enough. We could do it this way. We could just create a fraction strip here, and 1, 2, 3, 4, 5. We have 5 sections, so we have 5/5. Okay, so this right here is going to equal our answer. This is going to equal, finally going to equal our x. Okay, 1 whole x. But 1/5 of those is $800. Okay, because you can see that 800 equals 1/5 of x. Okay, so if the whole of x looks like this whole large rectangle, 1/5 of it is 800. We can just plug in another 800, and you see where this is going. Another 800, and then if you go 800 times 1, 2, 3, 4, 5, okay, that's going to give you, again, it's going to give you $4,000. Okay, so different ways to get the same answer. Like I said, not. Let's see how many did that. How many did we do there? We got 2.42 was our average there. Actually, had 1, 2, 3, 4, 5 students who were actually successful in getting that answer. Okay. So here we go. Let's move on. We'll go to D. D again. One thing that's really emphasized in this program is bringing everything back to the real world, and deciding what do these numbers actually mean. Okay, so what they asked you here to do, asked the kids here to do, was to describe what the point 0, 0 means. Okay, 0, 0, 0, 0 on the graph. Okay, so right here, describe. Again, that's the big word. Describe what the point 0, 0 on the graph are in terms of the situation being described by the graph. Now, the situation is the money the pop singer's earning. So let's see how we did there. We got, that's up to almost a 3 out of 4 on that one as our average. And quite a few people did a good job with this. What it means is for 0 sales, the pop singer earns 0 money. Earns $0. Okay, and that's just it in a nutshell, plain and simple. Okay, somebody wrote that, well, that's the origin. Okay, well, that wasn't what the question asked. Yes, it is indeed the origin. Okay, but what does it mean in terms of the situation being described by the graph? So, yeah, very, very proud of the many of you who did a very decent job on that one. Okay, so we have one last one last question, and that's E. Okay, so which point on the graph represents the amount of money the pop singer gets for $1 in money brought in from sales of the song by the store? This order, very, very important to read these questions very, very thoroughly. Okay, because if you remember what we said earlier, is we identified our X and our Y. Okay, let's see, where do we do that? Right here, yes. X and our Y right here. If you see, our X, remember, was the sales by the online music store. Our Y was the pop singer, pop star's dollars earned. Okay, so that's what we need to do. So if we're going to write our coordinates, and again, which point on the graph means that you need to write something in the form of X comma Y. Okay, X comma Y, and the pop singer gets $1, so that one goes here. Okay, a lot of well, actually, I'm sorry. Hold on a second. We got to look at that. That's not true. This is the here $1 in money brought in from sales of the store. Okay, so that $1 of money brought in sales, and that was, remember, that was X, because the X was the online sales. Online sales. Okay, so the pop singer gets. Now we're trying to actually figure out what that Y is going to be right here. We know that online sales were $1. Okay, what is how much money did the pop singer get? Now to go back and actually look at the graph to give you that answer is kind of tough, because look at $1 of sales is it's somewhere really, really close to here, and you really can't do it based on this just looking at the actual graph itself. But what you can do is you could use your constant of proportionality, because what this constant of proportionality is telling you right here is for every $1, as you can see right here, that the pop star earns, okay, there are $5 in online sales. And also, you notice right here, if we look at this one here, that is actually 20 cents. Okay, so the K, the pop artist, is actually earning 1/5 of $1. 1/5 of $1 for every $1 that the online music sales bring in. So 1/5 of $1 is 20 cents. Okay, that's 20 cents. Okay, so for every $1 the online store brings in, online sales, the pop singer gets 20 cents. And again, that can be seen because that is our unit rate, and that's actually what we're coming up with when we get our constant of proportionality. Okay, because we talked about Y as a function of X. Okay, so for every $1 that comes in, you get 1/5 of $1 to the musician or the pop artist, and that's what, 20%. That's probably not a bad deal if they're going to sell a lot of songs. So, well, that's it. That's the last problem. I hope this was 30-some minutes now. I really would appreciate it if you went over this a few times with your student, and if there are still lingering questions about it, I would like to hear from all of you or any of you. Okay, so again, look this over very carefully, and I will plan on sending a second version of this at some point as a retest. Okay.